Welcome, space enthusiasts. Today we're diving into the fiery heart of our solar system to explore how powerful solar flares affect not only our planet but the entire cosmic neighborhood. Get ready for an epic journey beyond the auroras. The sun is extremely active right now, unleashing the biggest solar storms we've seen in 20 years. These storms have triggered spectacular auroras on Earth, but their influence extends far beyond our planet. Let's uncover the full story. In May 2024, skywatchers at relatively low latitudes were treated to a rare spectacle. The powerful solar storm sent bursts of charged particles hurtling toward Earth, illuminating our skies with the flickering reds, pinks, and greens of the aurora borealis. The northern and southern lights shone farther south and north than usual, with sightings reported as far south as London and Ohio. Have you ever witnessed the mesmerizing dance of the northern lights? It's a breathtaking experience that leaves you in awe of the beauty of the universe. But did you know that these captivating light shows are only a small part of the sun's incredible power? Let's take a closer look at the science behind these phenomena and their far-reaching effects. But the sun's activity hasn't just fascinated us here on Earth. It has had profound effects throughout the solar system. Astronomers have looked far beyond our planet to see how these intense bursts of particles affect other planets and the space between them. Imagine a garden sprinkler spraying water in all directions. Now replace the water with charged particles and radiation. That's our sun during a solar storm. These solar particles travel vast distances and affect every planet they encounter. From Mercury, the closest planet to the sun, to Neptune, the farthest, the entire solar system feels the effects. Jim Wild, professor of space physics at Lancaster University, explains, "The sun can shoot material outwards in any direction, like a garden sprinkler. The effects are felt throughout the solar system. Our sun is heading for its solar maximum, a peak in an 11-year cycle of activity. This means more solar flares and coronal mass ejections, which can supercharge the Earth's magnetic field and produce magnificent auroras." But what exactly is a solar maximum? Think of the sun as going through phases, like the seasons on Earth. During a solar maximum, the sun is at its most active, unleashing a torrent of energy and particles. This increased activity can have dramatic effects, not only on our planet, but across the vast expanse of space. Matthew Owens, a space physicist at the University of Reading, adds, "Things really seem to be heating up at the moment. We're at the solar maximum, so we may see more of these storms in the next few years." Around the sun, several spacecraft are observing this increase in activity up close. These spacecraft act like vigilant sentinels, constantly monitoring the sun's behavior. They provide invaluable data to help us understand and predict solar storms. One such mission is the European Space Agency's Solar Orbiter. This spacecraft will begin orbiting the sun in 2020, giving us unprecedented insight into its activity. Currently on the far side of the sun as seen from Earth, the Solar Orbiter gives us a unique view of solar activity that we can't see from our planet. The storm that hit Earth in May originated in an active region of solar flares and sunspots on the sun's surface. Solar Orbiter captured several flares from this monster active region. Solar flares are sudden eruptions of energy on the surface of the sun that release large amounts of light and radiation. These flares can disrupt communications on Earth, damage satellites, and even endanger astronauts in space. Solar Orbiter observations are critical to understanding these powerful events and mitigating their effects. Daniel Mueller, project scientist for the Solar Orbiter mission, explains one of the mission's goals: to connect what's happening on the sun with what's happening in the heliosphere. The heliosphere is a vast bubble of plasma that surrounds the sun and planets as it travels through interstellar space. The heliosphere acts as a protective shield, deflecting harmful cosmic rays and particles. However, solar storms can disrupt this bubble, sending shock waves throughout the solar system. By studying these interactions, scientists hope to unlock the secrets of our sun's influence on space weather. This solar cycle, known as Cycle 25, is significantly more active than predicted. The U.S. National Oceanic and Atmospheric Administration NOAA, had predicted a maximum monthly average of 124 sunspots in May, but the actual number averaged 170, with one day exceeding 240. So, why does the sun go through these cycles? The exact cause remains a bit of a mystery. Scientists believe it's related to the sun's magnetic field, which undergoes complex changes over time. These changes drive the cycles of solar activity, resulting in periods of intense storms and quieter periods. The effects of these solar storms are felt throughout the solar system. Mercury, the closest planet to the sun, has a much weaker magnetic field than Earth and lacks a significant atmosphere. Solar activity can cause the planet's surface to glow with X-rays. Venus, which also lacks a strong magnetic field, still produces auroras when the solar wind interacts with its ionosphere. Imagine standing on Mercury and looking up at a sky glowing with X-rays. It's a stark reminder of the immense power of the sun. Venus, with its thick atmosphere, also experiences auroras, though they are different from the ones we see on Earth. These phenomena provide valuable insights into the dynamics of planetary atmospheres and magnetic fields. On Mars, the effects of solar activity are more pronounced. NASA's MAVEN spacecraft has been studying the Martian atmosphere since 2014. Shannon Curry, a planetary scientist at the University of Colorado, Boulder, and MAVEN's principal investigator, says, "We are now approaching the peak of cycle 25, and this latest series of active regions has produced the strongest activity MAVEN has ever seen. Mars, often called the red planet, has a thin atmosphere and a weak magnetic field. This makes it particularly vulnerable to solar storms. The MAVEN mission has provided a wealth of data on how these storms interact with the Martian environment, helping us to understand the planet's past, present, and future. Between May 14th and 20, MAVEN detected exceptionally strong solar activity, including an X8-7 flare, one of the most powerful types. Another flare, later estimated to be an even larger X12, shot X-rays and gamma rays toward Mars. NASA's Curiosity rover captured images of the Martian surface showing streaks and spots caused by charged particles hitting the camera's sensors. These powerful flares can dramatically change the Martian atmosphere. They raise temperatures and cause the atmosphere to expand, creating more drag on orbiting spacecraft. This poses significant challenges for future missions to Mars, both robotic and human. Solar flares have dramatically increased the temperature of the Martian atmosphere, causing it to expand by tens of kilometers. This expansion creates more drag on spacecraft, posing operational challenges. The increased radiation also degrades solar arrays on orbiting spacecraft. Imagine the entire Martian atmosphere inflating like a balloon. This phenomenon not only affects current missions, but also has implications for future human exploration. Ensuring the safety and efficiency of our spacecraft is critical as we prepare for the next giant leap in space exploration. Although Mars has lost most of its magnetic field, it still has remnant crustal magnetic fields that produce localized auroras. During a solar event, these charged particles light up the Martian sky and will be visible to future astronauts on the surface. These localized auroras provide a glimpse into the magnetic history of Mars. They also provide valuable data for understanding the planet's interaction with solar particles. As we plan for human missions to Mars, studying these phenomena will be key to ensuring the safety and success of our astronauts. Further out in the solar system, Jupiter, Saturn, Uranus, and Neptune also experience auroras caused by solar particles interacting with their magnetic fields. Although these planets are far from the Sun, they are not immune to its influence. Jupiter, the largest planet in our solar system, has a powerful magnetic field that produces spectacular auroras. Saturn, with its iconic rings, also produces stunning displays of light. Uranus and Neptune, the ice giants, reveal unique auroras that help us understand their complex atmospheres. One of the key effects of solar activity that astronomers are eager to study is the slow solar wind, a sluggish but denser stream of charged particles and plasma from the sun. Steph Yardley, a solar astronomer at Northumbria University, explains that the slow solar wind is generally classified below 500 kilometers per s, 310 miles s, and tends to be more volatile. The slow solar wind is a fascinating phenomenon. It originates in the sun's corona, the outermost layer of its atmosphere. Understanding the slow solar wind is critical to predicting space weather and its impact on our technology and exploration efforts. In May, Solar Orbiter detected a huge surge of ions moving at thousands of kilometers per second after a large solar flare. The spacecraft also saw large fluctuations in the magnetic field around it, caused by a massive plasma bubble ejected by the event. These observations provide a window into the dynamic and often chaotic environment of our solar system. By studying these events, we can better predict and prepare for the effects of solar storms on our technology and missions. Increased solar activity is a boon to scientists. If you track the number of papers produced by solar physicists, you can almost see an 11-year cycle in it, says Matthew Owens. We're all more scientifically productive when there's a lot of activity to study. Solar maximums provide a wealth of data that drives scientific discovery and innovation. As the sun continues to peak, we can expect even more groundbreaking research and insights into the nature of our star and its influence on the solar system. As we look to the future, the impact of solar activity on space exploration will become increasingly important. Earth bears the brunt of solar storms, but future missions to Mars and beyond will also face these challenges. Imagine a crewed mission to Mars traveling through the interplanetary environment for 6 months. Protecting our astronauts from space weather events will be critical. Developing effective shielding and safety protocols will be key to the success of these missions. The sun's activity is a powerful reminder of our place in the cosmos. From the stunning auroras on Earth to the far-reaching effects on other planets, solar storms shape our understanding of the universe and drive our exploration efforts. Thank you for joining us on this incredible journey through the solar system. We hope you enjoyed discovering the impact of solar flares beyond the aurorae. Don't forget to like, share, and subscribe for more exciting space content. And remember, keep looking up. The universe is full of wonders waiting to be explored.